Hello students, today I'll explain about the Ohm's law. Okay, in physics, one topic is the Ohm's law, very important topic that is for the class 10th, 11th and 12th. Clear? Topic name is Ohm's law. And the symbol of Ohm's law is this one, this is omega. The symbol is called as the omega. In Greek letter, it is said to as a omega. So, what actually Ohm's law will say? What is the statement? Okay, what the Ohm's law states? Okay, that we'll write first. That is the definition, very very important one. Okay, the potential difference. Okay, across across a conductor. Across a conductor, potential difference across a conductor is directly proportional clear is directly proportional to electric current clear to electric current at constant temperature, at constant temperature. Okay, the Ohm's law states this one. Okay, it states that the potential difference across a conductor, okay, is directly proportional to electric current at a constant temperature. So here some words are there: potential difference, okay, constant, okay, conductor is there, proportional is there, okay, and constant. These are the four words, important words. If you understand these four words, you can write the definition then. Okay, the law. Clear? So what is potential difference means here now? Okay, the work is done. Okay, nothing but a work is done per a unit charge. Okay, the movement of a voltage. The work is done here. So from one point to other point, it's called as the potential difference. Okay, the movement of voltage. Okay, from one point to other point. The work is done then. Clear? Suppose this is the wire. This is the conductor. The wire, metal wire is called as the conductor here. So the electrons are moving here, not moving in a perfect random direction. They'll be in the random direction here. But when you apply the voltage to it, okay, when you make a circuit and apply the voltage to it, then what happens? Potential difference occurs here. It creates here now. Then electron will move in a straight line. Okay, even though they are moving in a straight line, they'll touch the lattice particles. They are nothing but the protons. Protons will not move, so they'll touch there, come back, and once again move. Once again come back. Once again it will move. So the movement, but the movement will be in the straight line. Okay, the electrons can go here because we are giving the pressure to it. Okay, external energy is given to it. There is nothing but a potential difference, PD, nothing but voltage. Clear? So then it will move here. So there is a potential difference. Then across a conductor, what is a conductor? The wire is a conductor. This is the conductor. Okay, on which the electrons are moving. Okay, suppose if you will not give the current to it, voltage to it, then also the electrons are moving here, but they'll be moving in a random. Okay, random motions here and there, and they'll move. Particular position they'll not move here. Okay, but when you apply the current to it, then they'll go in the perfect way. Clear? There is a conductor. Conductors are what here? Conductors are those which can allow the electricity in a simple way, easily way. And many are there. Many conductors are there, like aluminum is there, copper is there, gold is there, silver is there. These are all the metals, especially metals. They allow the current electricity, okay, to move easily through them. They are the conductors here. Now, what is proportional? Proportional constant. Already these two words are many times we have discussed in the mathematics. Isn't it proportional line? Here, the variable, okay, maybe the variable V and I will be different here, but their ratio will be equivalent. Okay, the variable V, there is V nothing but a voltage, I nothing but a current. Okay, maybe their voltage will be different, current will be different, ampere. Current is measured in the ampere here. Voltage is that their numbers will be different here, but their ratio will be equivalent. Clear? So that is a proportional. The constant is a known one. Okay, a known here. Okay, a known value, a constant value. Clear? So this Ohm's law states this thing. Clear? Hope understood here. The potential difference across a conductor, directly proportional to the electric current, directly proportional to the electric current at a constant temperature. Clear? Now, based on this, based on Ohm's law, one activity is there. Clear? We'll do one activity now based on Ohm's law. 6 marks activity. This definition of this law carries 2 marks. Okay, symbol of Ohm's law is this one, omega. Clear? The question will be show that the ratio of the V by I, okay, voltage by current, is constant for a conductor. Okay, that is the question. Clear? Show that to prove that the ratio of a velocity, the V by I. What is V here? Voltage. Clear? Clear? It a constant here. It a constant. Constant. Clear? It is a constant. V by I is a constant. Is constant. You can write directly here. Is constant. That we have to prove. Okay. Where it is constant for a conductor. For a conductor. So just now I told you what is a conductor means. Conductor is nothing but a metals. Especially all the metals it has a conductor only. Clear? So for this activity, for experimental based question, some things are very important. Aim is there. Requirement is there. Okay. Aim. Then aim is a requirement, procedure, observation, okay, conclusion, precautions. This all the step by step. So if you do it, you'll get a 6 marks. Okay, so like that we'll do here. Aim here. What is the aim you have to write here? Aim. What do you have to write aim here now? To show that. To show. Okay. To show that. What do you have to show now? The ratio of. To show that the ratio. Okay, the ratio of voltage by current, okay, potential difference by current, clear, is constant. Is constant. Is constant for a conductor. Clear? For a conductor. For a conductor. Clear? This is the aim. Now, what is the requirement for this? Requirement. What are the things we require here now? The first one, very important thing, the first one is ammeter. The first one what we require is the ammeter. For the second one, voltmeter. Voltmeter. Clear? And for the third one, batteries. Batteries are there here. Batteries, 4 to 5 batteries you can take care of. Okay. Then fourth one, switch key. Switch key. Okay. Ammeter, voltmeter, switch key, battery, and what is the other one here? Copper wire, insulated copper wire. Okay, insulated copper wire. Clear? Insulated copper wire. Clear? Now these are the things. And one important thing what we have to do here, that is your conductor. That is nothing but iron spoke. Iron spoke. Okay, iron spoke. Iron rod. A small, iron rod that is act like a iron spoke. So these are the requirements. These are the requirements for this experiment, for this small experiment. Clear? This carries 6 marks. Clear? So what is the aim here now? To show that ratio of voltage by current, potential difference by current is a constant. Okay, for a conductor. Conductor is nothing but a metal wire. The metal wire. Then requirement. What the requirement we need here now? Requirement is ammeter, voltmeter, batteries are there, insulated copper wire is there, switch key, iron spoke here. Insulated copper wire, what are the wires we are using in the home? They are the insulated one. Plastic will be there. Okay, this is the wire. Plastic will be there here, so that if you touch it here, you will not get the shock. Clear? That is the insulated one. Plastic or the rubber. Clear? That is the insulated one. Insulated copper wire. And what is the next one? Voltmeter, ammeter. Ammeter, voltmeter. What these two will do, Ammeter, this is the instrument, or this is the device to measure the amount of current. Okay, amount of current, how the current is moving, whether current is moving or not, amount of current here. Now voltmeter is there. What is the work of voltmeter? What this device will do? It measure the potential difference from one point to other point. Clear? One point to other point. Now along with the diagram, I will show you how we will do this activity. Clear? Note down this one. This is very important for the 6 marks. And last of this topic, last of my video, last I have given the answer also. I'll give the answer. Okay, complete answer I'll give you, and some little information about the Ohm's law. Clear? That also you see it. It will be helpful for your answer, to write the answer. Clear? So these are the requirements. Now after requirements, what we have to do? Procedure. Clear? After the requirements, aim you have written, requirements we have written. Now the procedure. Procedure. In procedure, what should be the first line? Arrange the apparatus as shown in the figure. So what is the first line you have to write? Arrange the apparatus. Arrange the apparatus as shown in the figure. As shown in the figure. Figure you have to draw for the long answers. Okay, for the long answers, you have to draw the diagram. Compulsory, you have to draw the diagram. So this line is applicable there. So in procedure, the first point should be arrange the apparatus as shown in the figure. Now we'll draw the here arrangement we'll do. So what we have taken? Iron spoke we have taken, isn't it? So draw the iron spoke one. This is the iron spoke. Imagine this one is the iron spoke. Clear? Now to this iron spoke, connect, solder the wire. Okay, solder the wire. Okay, clear? This is the circuit now. Circuit is prepared. Clear? Now arrangement I'll show you. Clear? What is this one? This is the iron spoke. Nothing but a conductor. Okay, listen carefully. Iron spoke. Nothing but act like a conductor. Even this wire is also called as a conductor only. Clear? So now here what we have to keep here? Ammeter. Keep ammeter here. Clear? This is the ammeter keeping. Okay. Remember this one? Ammeter is always connected in series only. In series, we have to connect the ammeter. Clear? But voltmeter, it should be connected in parallel. Here we have to connect. It should be connected in a parallel to the series here. Okay. This is the voltmeter. Here we have to keep the voltmeter. Clear? This is the ammeter. Okay, and this one is the voltmeter. Clear? Both the device we kept here. Now, what we have to keep here now? Here we have to keep the battery. Okay, if one cell is there, if only one is there, they call cell. If more than 1, 2, 3, 4, 5, it is called as a battery here. Anyhow, we'll start with the battery. Clear? Here we kept the battery here, and here switch key. Here we kept the switch key. Clear? Ammeter, voltmeter. This one is the battery. Battery, positive, negative show the charges here now. This is the battery. This is the key. Switch key. And what this one here? This is a wire. This is the wire. Clear? Now where the positive, where we kept the positive here now, from there only the current move. Clear? This is the movement of current, flow of current. Clear? This complete is said to be as a circuit. Clear? What does this call as here now? Circuit. Clear? So after solidify this wire, everything, switch on the key. Once you switch on the key here now, the current flows. Okay, when the current flows here now, the reading in the ammeter and the voltmeter, they'll show their readings now. Okay, in a voltmeter, in ammeter it shows in ampere. Current always shows in the ampere only. Okay, then it shows the potential difference here, voltage. Okay, voltmeter shows the voltage or potential difference here. Now by seeing this one here now, we have to make one table. Okay, one table you have to make. Okay, by changing the batteries here. Okay, that is our experiment. Clear? So we'll do that here now. One table. Okay, everything, the reading should be in the tablet form. Clear? So serial number. Okay, then voltage, current, and the ratio. What is the ratio? V by I. Clear? The first one. Clear? The first one. Okay. This carries 6 marks, so check it properly. Okay. Clear? Check it properly. Now, when we on the switch here, how many batteries we kept here? Only one, just one cell is one. Okay, the current moves here. One reading will come here. In ammeter, one reading will be there. In voltmeter, one reading will be there. Okay, imagine in voltmeter it is 15. Okay, the reading is only the example, just an example. Okay, and current ampere is 5. So V by I. Okay, that we have to show here, constant we have to show here. So 15 by 5. So how much answer we have to we are getting here now? 3. 5 ones are 5 3s are 15. Okay, then the second one. So here increase the shell. Okay, now you have to increase here. Once again, clear. Next battery, second battery. Now check once again on the key and check the readings here in ammeter and voltmeter. Now imagine this in the second here 21 we are getting. Suppose example, just only example. Okay, 7 ampere. Then 21 by 7. So how much answer you are getting here now? Once again 3. Okay, 7 ones are 7 3s are 21. Okay, next third one here. Now apply the next third one. Next keep the next battery, third battery. Clear. The third one we are playing the next 1 2 3 are there here. Third one here. Okay, next reading suppose 27 27 9 ampere. Clear. So 27 by 9. What is the answer you are getting here? Once again 3. Clear. So once again fourth one, next battery. Here once again we are keeping one other battery. Clear. Next battery, fourth battery here. Okay, example like 30. Suppose 30. Voltage is 30. Ampere. Okay, current is 10. So how much you are getting? 30 by 10. Once again you are getting how much here now? 3. Okay, once more. Okay, once again we are adding the here battery. Next battery. Okay, the final one here now. Okay, the fifth one here now. The final one. Okay, now here suppose 45. Okay, here 15. 45 and 15. Then what we are getting? 45 by 15. So 15 ones are 15 threes are. Clear? So what you have examined here now? Okay, what you have observed here now? Okay, what is your observation? Observation is what in this experiment here now while doing this activity here now. Continuously we are doing the activity by supplying the current voltage more. First battery, one battery, second battery, third, fourth, fifth, like the batteries. And what will here now? Maybe the variable will be different here, but their ratio will be constant. Their ratio will be same. They will be constant. Clear? Understood? You know? Say 3, 3, 3, 3, 3. This is only the example here now. Okay, this is only example here. Clear? So I have taken some values here. But actually, when you keep the battery, the battery voltage will be different. Have you seen the battery? Small battery, different market batteries are there here. Okay, in the batteries there will be written voltage on the 1.5 volt, 2.5 volt, 1 volt. Okay, so voltage, different voltage batteries have taken and added to here now. So different voltage I'll get, different current I'll get. But even though voltage and current is different here, but their ratio is same. Their ratio is completely same here. Okay, this indicate what here now? What does this indicate? What this table indicate now? That is V by I, voltage by current is nothing but is a constant. This we have proved. Okay, V by I is nothing but a constant. Clear? By table. Okay, number of times you have done this experiment. Okay, number of times by adding the batteries to it. When you add the batteries to it here, now different readings you are getting. Okay, different readings you are getting in ammeter as well as in the voltmeter, but their ratio is always constant, equivalent. Clear? This is the example. Okay, this is the activity. Clear? The same thing. Okay, this if you do here, and if you write in a systematic way, aim, requirement, procedure, what we have done, the observation here now, what we observed here now. Okay, step by step we have observed, isn't it? When we increase the batteries here now, we have seen the increase in the ammeter as well as in the voltmeter. Okay, third battery, fourth battery, fifth battery. Okay, the values will be changing here now. See, volt 15, 21, 27, 30, 45. Current also different 5, 7, 9, 10, 15. But see the ratio here now 3, 3, 3, all are same. Okay, so V by I is nothing but a constant. It is called as the constant. Clear? Understood? So what is the ammeter is doing? Ammeter is nothing but it is a device or the instrument to measure the amount of a current in a wire. Okay, amount of a current in a wire. The current is moving like this. So that is the work of a ammeter. What is the work of a voltmeter? What is the main work? It is a device to measure the potential difference, voltage. Okay, voltage. Okay, between the 2 points. Okay, point A and point B. Listen carefully. These are the 2 points. Here we kept the iron spoke, isn't it? So it shows the potential difference between the point A and point 2. That's the work of the voltmeter, Clear? Now, what is the conclusion we got here? After doing this experiment, what we got the conclusion? Conclusion is that here, when we increase the battery, automatically what happened, the current, everything will be increased here. Okay, whenever apply the battery to it, the ammeter and voltmeter will increase the readings. Even though the difference are there between the readings, okay, voltmeter and current but their ratios is same. And by seeing this here now, it is said to be V by I is nothing but a constant. Clear? Let's do here now. Next one I'll show you. This is only the example, okay? Actually, when we take the batteries, when we do this experiment along with the batteries, the reading will be different. Okay, the reading will be different, but their ratio will be same, equivalent. Okay, the ratio will be same. Clear? So, what is the ratio we got here now? V by I is nothing but is a constant. Is constant. Clear? Now, for constant, the scientists have given one word to it. Okay, V by I is equal to R. Okay, the R word is introduced here, and what is R means? Resistance. What the R is nothing but a resistance. Clear? What the R means here? Resistance. So V by I equal to R. Clear? So cross multiply if you do it here now. What you are getting here now? V equal to IR. Okay, this V equal to IR is nothing but Ohm's law. This is the Ohm's law. Clear? This is the Ohm's law. Okay, so if you remove the R here in mathematical unit, if you remove the R here now, the V will be the proportional to I. Okay, remove the proportional resistance. Clear? Okay, in mathematical we are studying the same thing here. Clear? Proportional and resistant. So what are the resistance means? Property of a material that opposes the flow of current, flow of electrical charges. Okay, through it. That is called resistance. Okay, how the current is moving. Okay, how the electric charges are moving in a where it's moving in a material. What is the material? Copper, gold, silver, aluminum. This all thing. So resistance is that one, the property of material, okay, that opposes flow of electric charges, okay, through it. Clear? That's the here. The important thing is what here? Resistance if increases, then the current will be decreases. Resistance if increases, the current will be decreases. And opposite to it, resistance if increases, the current will be decreases. Later we'll study this experiment also is there about that. Clear? So these are the examples. Clear? The same answer have attached the paper to my video here. You can take down that answer here. Clear? Hope understood this whole thing here. Clear? So this is about the Ohm's law. And depend upon the Ohm's law. I'll show you. Ohm's law we can show in triangle way. Okay, Ohm's law we can show in triangle. Clear? If you want to show the V, so what we'll do here, if you want to show the V value, V equal to I into R. Clear? If you want to show the I current here, then I equal to V by R. Clear? If you want to show the R, the resistance here, R equal to V by I. Clear? This is the triangle way. Okay, Ohm's law shows in the triangle way. So based on the Ohm's law, ohmic materials also are there. It's a very, very important one. Very, very important one. Depending upon the Ohm's law, okay, the material are of two types. So, based on the Ohm's law, two materials also are divided to here. Clear? What are the material? Ohmic material. Ohmic material and non-ohmic material. Ohmic material and non-ohmic material. Clear? What are the ohmic material? All the conductors, metals, especially metals, which allow the electrical charges to freely flow. They are the conductors here. And here ohmic materials, we can show the graph also. Okay, we can show the graph. This is the voltage, potential difference, current. Okay, the graph in ohmic material will be straight. Okay, clear, it will be straight. This is in ohmic conductor, the graph, okay, the line will be straight, clear. But whereas the non-ohmic conductor here, okay, volt and the current, it will be curved, okay, in a curved line, clear. Ohmic conductors and non-ohmic conductors, clear. All the conductors in the graph shows this straight line here. Ohmic conductors are the metals, all the metals here. Non-ohmic conductors, what are they? Semiconductors are there here, gaseous conductors are there. In the next topic, we will study what is semiconductors, what is gaseous conductors here. But these are the graphs. Graphs will come for 4 marks. This is a very, very important, what are difference between ohmic material and non-ohmic materials. Okay, based on the Ohm's law, the material is divided into 2 types. Okay, ohmic material and non-ohmic material. Ohmic materials are all the conductors here, metallic, all the where the current flows easily, clear. Okay, and the graph will be in the straight line. Non-ohmic materials, semiconductors are there, gaseous conductors are there, in which will happen the graph will not be in the straight line, it will be curved there. Clear? There was the here. One another thing, after explaining this very good explanation about the ohms, he has given the very good explanation about this whole thing, but he too have some limitations. Okay, Ohm's law have some limitations. What are limitation? 1 or 2 limitations only, not more than that. Okay, very limitation. What are the first one? It is valid. Okay, it is valid at constant temperature. Limitations. Limitations of Ohm's law. Of Ohm's law. Okay, what are the limitation? What are the first limitation? It is valid. Okay, valid at constant temperature only. It is valid at constant temperature. Constant temperature. Constant temperature. Just now we have done one experiment. One experiment just now we have done. Okay, in a circuit here we arrange the first battery, second battery, third battery, and we have all the recording we have checked. Each and every recording we have checked, and that thing we are doing at room temperature. Clear? Now example, same thing. Suppose the same thing we are doing in another room. Imagination, just imagination. In that room, minus 2 degrees, minus 10 degrees, 30 degree temperature, cool, chilled, total chilled. Same experiment we are doing. One we are doing here now. One battery we kept in room temperature here. Second room, and the second battery we kept in the other room, but the temperature is different there. Minus 5 degrees, minus 6 degrees. Then your readings will be affected. Okay, again third room we went. That room temperature is totally high, 45 degrees, 50 degrees. There we kept the third battery. Then once again we have checked the readings here. All the readings will be different. Why? Because of the environmental disturbance. Okay, environmental. Okay, depend upon the environmental. That's the reason. Limitation is what valid at constant temperature only at one room. At room temperature, if you are doing this experiment, you'll get the values accurately. Perfect value you'll get it here. Clear? If you go to ice, that means temperature which is minus 5 degrees, 10 degrees here. There, if you do all the first battery, second battery, third battery, according to that temperature, your complete readings will be correct. Clear? So indicate that this valid only at constant temperature. Clear? Now, what are the next one? What are the next one? Okay, limitation. The next one, obeys by the conductor. Okay, obeys by the conductors only. Obey or obeys by conductors only. Conductors only, not by the semiconductors or gaseous conductors. Okay, it will not obey. Obeys by only conductors, metals, especially metals. Copper is there, aluminum is there, silver is there, gold is there. These are the material, these are the metals from where the electrons, okay, the electric charges can easily flow. Freely they can flow here. Clear? These are the 2 limitations. Clear limitation. So for doing this this experiment here now, activity here now, some precautions are needed here. Okay, what are the precautions here now? Some precautions are there. When you do this complete experiment, see that you should not do that experiment near the water bodies. Okay, water bodies. Clear? Water bodies should not be near to it. Any water bottles is there, any big water tank is there, electricity, you know that. Okay, electrical experiment should not be near the water. You should not do near the water, clear. Shock can be observed here. Second is, here we have to see that what the device you are taking, ammeter you are taking, as well as voltmeter also you are taking. It should be updated. Okay, what is updated means, new you can take here. If you are taking the old one, old ammeter, old voltmeter, if you take here now, the reading will be different then. Okay, what the Ohm said, it will be wrong then. That sentence, the law will not be correct then here. So if your accurate value, the ammeter and the voltmeter giving the accurate value to it, then the experiment will be perfectly good here. Clear? Well, these are the two what you can do here now. Other also are there. Water bodies are there, and ammeter voltage update should be here now. Then third one, you can tell you have to take only insulated wire. Insulated wire. Insulated copper wire or any wire. It should be insulated. What the insulated means, rubber should be there, plastic should be there. What the wire you are using at home here, it will be insulated on. If you hold it, you will not get the shock because the wire will be inside. Clear? Outside what happens, the rubber will be there or the plastic will be there. There's a conductor. Clear? So in insulated only we have to take here. Ammeter voltmeter should be correct, it should not be near to the temperature. Okay, water body here. High temperature also we should not do here. If it is too much high temperature near any electrical appliances, near also that you could not do. Fourth one also you can write. These are the precautions. Okay, near the electrical appliances. Near electrical appliances also can't do. Okay, fridge is there, big machines, motor machines are there. Maybe it shows the different reading then in your ammeter and voltmeter. It affect magnetic field effect then here. So it should be away here. So these are the precautions. That definitely you'll get the 6 marks. Okay, systematic way if you write it here. Okay, so definitely you get it. Aim is there. How you write the systematic? First you write what the Ohm's law states. Okay, then what do you write? Aim you have to write. Okay, aim the same thing. What are the aim you should write? To show that the ratio of the V by I. V by I is a constant at a conductor. Then what are the requirement? What are the requirement? We are taking ammeter, we are taking switch key, we are taking voltmeter, and iron spoke we are taking, etc., etc. Okay, then procedure. Don't forget this line. Procedure: arrange the apparatus as shown in the figure. Then do it. Then what are the activity we have done just now? Then conclusions are there, observations are there. Finally, precautions. What are the precautions we have to take here? Clear? This answer, this complete answer, I have attached that small video to this explanation here, so that you can write that answer. Clear? Hope everybody understood. Thank you.